Okay, so you need to know that it's a parabola. You also need to know that the equation for it looks like this right here. Y equals ax squared plus bx plus c. Now, so all of the equations we're going to look at are going to have an x squared term. The x term and the constant term are optional. Now, the reason why, if you look, this is the form, but it is where a can't be 0. Guys, don't play with the blinds. Now, so, guys, Cole. What?
What's that? Wait, is that like a typo or something, or is that real? Like the A, little weird sign 0.
That's not equal. That says a can't be 0. A, guys.
So like A, like a no zeros in. Oh my god.
This is saying that a can be any number other than 0. It can be a positive number. It can be a negative number. It can be a whole number. It can be a fraction. It can be a decimal. Now, guys.
It's fine, just throw it away. Just throw it away. Actually, I have an idea. I'm sorry. Eating it?
Yes. Huh?
I need more water in it. Oh my gosh.
Okay.
Really? It's already too cold. It's dead
anyway.
Wait, where do you need to go? Scholar pool. Bye.
All right.
Good luck, Scholar.
Now, for our purposes, the equations you look at are actually going to look like
Just throw the worm away.
this.
It's dead. It's dead.
Guys.
Copy.
Now, again, we're looking at the very basic beginning part of quadratic equations. When you guys get into more advanced math, you'll start looking at how adding a number can adjust where the vertex is and things like that. For right now, we're eliminating that bx term because it makes them simpler. Okay, so this is all the ones that you guys look at are going to look like this, where you're just going to have an x squared term and then possibly a constant term. Now remember that constant can be 0, so you could end up with just something like y equals 3x squared, where it doesn't have a constant term added on because 0 is a number, you can add 0. Okay? The only thing that can't be 0 is the a term. In other words, there has to be an x squared. If you take out the x squared, like let's say I take that equation, and let's say I let a be 0, well then I have 0x squared, so then I'd have like 3x plus 2. Well, is that going to be a quadratic equation? Look at that. What is that? That's a linear equation, right? So the thing that makes the difference between it being linear versus being quadratic is that it has to have the x squared term. Okay? So that's what you're looking for, is terms that have that x squared term in it. If it has y equals x squared, 3x squared, a half x squared, whatever. If it has x squared and that's its highest exponent, then it's going to be a quadratic equation. Now, again, we're going to be looking at just the basics of quadratic equations, so we don't have to worry about memorizing all the different ways that you find the vertex. All you guys need to know is how to fill out a t-table. We have already done t-tables. However, judging from papers that I graded, I think some of you didn't really grasp the concept of a t-table. So, let's look at this one that they filled out here. This is our equation. Y equals x squared minus 3. If we want to graph it, first of all, we know that it's going to have this general shape, right? Then we also know that if I plug in x values, I should get the y values that match with it, right? Now, because of the fact that we don't have this term, because it's just all the ones we're looking at, if you look at the examples 1 through 6 at the bottom of the page, notice none of them have just x. They all have x squared and then a constant. Because of that, all of ours are going to be centered around our y-axis. I'm telling you this because I don't want you to, next year, get an equation that has an x term in it and go, oh no, Miss Nichols told us it's always centered around y. Well, no. It's only centered around y if there's no b term in there, if there's no x. Okay, if it's something x squared plus something or minus something, and there's no x term, then it's going to be centered around the y-axis, meaning that the middle of the graph will be on the y-axis, right? Like here or here, okay? On the y-axis is the center. We call this the vertex of the parabola, the place where it curves upward or downward if it's downward facing. But the place where the two sides meet in the middle, that's called the vertex. Now, guys, now look, when I make a t-table, I don't make this middle column that they do. All I do is put my x values, so -2, -1, 0, 1, 2. And then I plug it in either on my head or on scratch paper. So I'd say, okay, if x is -2, here's my equation, right? Zach, you with me? Here's my equation. If x, the first value I'm picking for x is -2. So up here, I'm going to replace x with -2. So I have -2 squared minus 3. So y equals 1. So when x equals -2, y is 1. That's what they have right here. That's all that is. That's all they're doing. Right. Y equals 1. X equals -2. Y equals 1. This is a specific value for y given a specific value for x. Now we're going to pick a different value of x and find what the matching value for y is. So then we use -1. So same equation, y equals -1 squared,
I have a question.
which is 1, minus 3, which is, so that's where that -2 comes from.
Miss Nichols, I'm sorry. Can you just do like a pattern? Since like it's like a pyramid, so it's like 2, 2, 2.
Well,
That's
do
a
you
diamond.
think that it's always going to have that pattern?
Okay, I got it.
All right. Now, for 0, we plug in 0 squared, which is 0, minus 3 is -3.
-3.
Now, as Cam so astutely noticed here,
Yeah, it's not a diamond.
we do have a pattern because this shape is a
Horseshoe.
parabola, which means
What?
that if this value is 1, then this value, y value, is 1 because they're mirror images of each other. Okay? So -2 gives us 1, but +2 is also going to give us
-1. No,
1. Okay? The reason why that happens is because -2 squared
Is 4.
and +2 squared is also 4. The reason a quadratic equation gives us a parabola is because we're not going to have negative values, because when you square something, it's going to make it positive. Now, sometimes you'll have negative values because you're subtracting something, and the thing you're subtracting is bigger than the positive value. So you may have it be negative down here, but when you square the number, even if it's a negative number, it's going to make it positive, right? So that's why we're going to end up with this shape. And they're all going to look like that. So as long as you pick, 2 and -2, or 4 and -4, or 7 and -7, and again, we don't have that b term. That term will throw that all off because it's going to change where your center is. But as long as we don't have this term, which none of yours will, then your middle is always going to be 0 on your x, which means 1, and if you plug in x is 1 and -1, you'll get the same y value. And if you plug in x is 2 and -2, you'll get the same y value. So this would be -2 and this would be 1. All right?
Wait, alright.
Yes. Okay. All right, now from here, what?
Alright, so don't you always like just straight line between points?
No, because it's not a linear equation. All right. Okay. Now. All right. From here we need to graph it. Now, you're going to graph the 5 points that we came up with from our t-table. So we're going to graph -2, 1, -1, -2, 0, -3, 1, -2, and 2, 1. Now one thing that I don't like that they did on this example is they went by 2s and they didn't really label that they were counting by 2s. That's why we have these points that are like halfway up. Yeah, they really should have labeled that. So if you want to like make a little note to yourself, like this is 2, 4, and you know like that 2, 4, so that you know that they're counting by 2. Because otherwise it might be a little confusing.
I looked over and I saw it.
No, you can't tell from the exponent. That's just your graph. Okay, guys, one thing that's important to know is you can draw your graphs however you want, okay? As you guys get to, you know, be bigger kids and you make your own grid lines, yeah, you no longer get the pre-numbered and labeled graphs, okay? So, as you are, guys, listen, don't talk. As you are working with blank graph paper, and you can draw the graphs the size you want. Well, obviously, if your graph goes up to like 297, you don't want to label every one because then your graph paper would have to be 297 units long. So you have to learn to draw your graph paper with units that are appropriate. Okay? Now, in this case, they labeled every 2. I really don't know why they did because they had plenty of room to graph it down to -3, but they did. So again, I don't know why they did it and didn't even label it. But anyway, that's what they did. So that's why this is 0, -3 because we go left, right, none, and down 3, which since it's going by 2s, that's 2, and then 4 would be there, so 3 is right in the middle, right? So that's 0, -3. 1 is only going to be halfway over because this is a 2. So 1 is halfway over. And so at 1, guys, at 1 we have -2. So down here at -1, so halfway this way, we also have -2. And then at 2 we have +1. And at -2 we also have +1. So those are our points. And then you do not connect them using a straight line because this is a quadratic equation. It's not going to be a straight line. If I found the points that are in between, these two, they're going to lay on a curve. But this is just sketching. You don't have to be exact, but you need to understand that a quadratic equation is a curve. Okay, so it's going to be it's not straight connect the dots lines like when you do your graphing pictures. It's going to be a curve, and you just kind of curve it through, and it should kind of flatten out at the bottom, and then curve back up, okay? So that's what your graphs of quadratics need to look like. So you graph 5 points, and then you draw a curve going through those 5 points. Yes, together. All right, so let's see. Let me get another example here. So we're going to look at example number 1. Actually, I think I can do it this way.
Is that one right? Or are we about to go over it? Do I need to
Yeah, we're going to go over one, right?
Yeah, hang on. No, because remember it's going to be, well,
I didn't mean to do those because I got to make like the numbers.
Are you counting by 2s again?
Uh-huh.
Yeah, it's probably right. Let me. Yeah! All right. Okay.
We have like 6 tests on this.
Yeah. Guys. Shh. All right. Cameron just asked, does it matter what you use as your x values? Again, you can use anything, but because you know it's going to be a parabola, and because you know it's going to be centered around that x equals 0, the y-axis, you really want to use 0 and you want to use a couple points that are below 0 and a couple points that are above. So my suggestion is, for the most part, use -2, -1, 0, 1, 2 as your x's. You don't have to use exactly those, but you need to at least use 0 and a couple that are above 0 and a couple that are below. Because, guys, if you don't do that, if you pick all positive values, then your graph would look like this, and you wouldn't see the parabola part. You have to have the values above and below whatever that middle part is, or else you're not going to see the parabola. All you're going to see is kind of a curvy line going that direction. All right? So, all right. Yes. All right. Okay, so the first thing you need to do on each of these is that you're going to create a t-table. So, I have...
I'm trying to type in my homework. What?
Okay, guys, you have an online agenda.
I'm being corrected.
Now,
What? I'm like you people.
pull.
Sorry.
All right, so for this one, again, my suggestion for the most part, I would use -2, -1, 0, 1, and 2, just because that way it's going to be smaller, so that way you don't need as big of a graph paper to show it. Because if you start using really big values, now the one exception, we're going to look at number 5, and because we have that 1/4 in there, you might want to pick slightly bigger values so that they're easier to take 1/4 of. But again, as long as you pick 0 and 2 things below 0 and 2 things above 0 as your x, then you should be fine. All right. Yeah, we're going to do it. We're going to do that one next, assuming we have time to do it, which we might not because y'all... Now, remember, whatever we don't finish, you do as homework. So the more we get to... Yeah. No, right now we're doing number 1, and then we're going to do number 5. Now, plugging in to equation for number 1, we have x squared plus 2. X is -2 first, so -2 squared...
-4. Oh, 4.
4.
How?
Negative
Negative
2
2
times -2. Remember, squared means times itself 2 times. So -2 squared means -2 times -2, which is +4. So 4 plus 2 gives us 6. Thank you. Now, because of the fact that this is going to be a parabola, and because we know -2 squared and +2 squared gives the same thing, I also know this is going to be 6 right there. If I do -1, -1 squared is 1, and 1 plus 2 is 3. So this is going to be 3, and also 1 is also going to be 3. Because again, -1 squared, +1 squared, both give us the same thing. And then the last one is 0. 0 squared is 0 plus 2 is 2. And one thing you'll see is, again, just like with linear equations, if you have a constant added on, that's going to be your y-intercept. Because when x is 0, all the other terms go away and all that's left is the constant. So whatever your constant is, that's going to be your y-intercept. So when x is 0, that's what you're going to get. So like when x is 0 on this one, it's going to be -1. When x is 0, this one's going to be 2. When x is 0, this one's going to be 0 because there's nothing added on, right? All right, so now to graph it. Now when we're graphing this, now again, for this one, you have 2 choices. You can either count by 2s, because this graph goes up to 6, and there's only 5 squares. Or the other option is you can just kind of sketch in a sixth one. I don't really care. In fact, we'll do that on this one. So if I do that, I have negative 2 6, so I'm going to go to left 2 and up 6, which is going to put it roughly up there, right? Kind of under where that my 2 is. Okay, then I also have positive 2, guys. I also have positive 2 6, so I'm going to go to the right 2 and up to about where 6 would be. Negative 2 6 means to the left 1 2 and up 6. So
They're by twos.
Oh my god. We just said that we're gonna add one.
I said you can count by twos. The one example we looked at, they counted by twos. You get to choose whether you want to count it by twos or not. I don't particularly want to count it by twos, so I'm just going to count it by ones here. Okay? Because I don't really want to count it by twos because then that negative 1 is going to be halfway between, and I really don't like the halfway points unless I have to. So, yes, you can do twos if you want to. Again, it is your choice. All right? Then, just make sure, guys, if you do anything other than ones on a test question, you need to label what you're counting by so that I know what you're counting by. All right. Then we have negative 1 3, so I'm going to go to left 1 and up 3. I also have positive 1 3. And then I have 0 2. So that's my 5 points. And then I just draw a curve roughly going through. Yes, you need to draw arrows. Really?
Yeah, but like if you draw the line, then it goes on forever.
Y'all complain about the weirdest stuff. I mean, really. Of all the things to complain about, she's upset because she has to draw arrows. All right. All right. Now, it is really hot in here. I don't know what's going on. All right. So that's 2, so that's 3, that's 6. Yep. All right. Okay. Let's talk about number 5. We probably won't get to graph it, but we can at least draw our T-table. Yeah.
Oh, I wasn't on that thing.
All right. Okay, so for this one, guys, again, I definitely want to use 0. And since there's nothing being added, since this is plus or minus nothing, if I plug in x is 0, I get 1/4 of 0, which is still 0. Yeah. Now, you can still pick negative 1, negative 2, 1 and 2, but I'm not going to pick 2 and 4 and negative 2 and negative 4 just because I'm doing 1/4 of something, which makes it slightly bigger numbers to work with. So if I do that, plugging in, I get 4 squared, which is I used 4.
16.
16.
Bang bang. No.
4 times itself.
That means 4.
You might want to use your calculator to do your experiments because you seem to be glitching back to multiplication. So 4 squared is 16. 1/4 of 16
Is 4.
is 4. So 2. Yeah, and then negative 4 is also going to be 4. All right. Then 2 squared is 4. 1/4 of 4 is
0.25.
1/4 of 4 is 1. And then that means negative 2 is also going to be 1. So then graphing this, now this one you can see none of my values are any higher than 5. So this is a good one to go by ones because everything shows up nicely on the graph that way. So I'm going to graph 0, 0. So that's going to be right there in the origin. I can graph 2, 1. and -2, 1, and then 4, 4, and -4, 4. Huh?
Are you going by ones on this one?
Yes. Again, the only reason I would do anything other than ones is if I have values that won't fit on the graph if I go by ones. Like, but see, this shows through 5.
What do you forget about?
So since this shows through 5, it makes the most sense to count by ones.
But I like to stick with one thing, because then I'll get
I really don't think I can give you any more time on this. I mean, you had 2 entire class periods plus the connections. I think I'm going to have to grade what you got on it. Yeah, I mean, it's a guessing. It's something you can guess on, and I would guess on them. And air conditioning won't run, so when it got too hot, it won't let me cool it off because the air just doesn't take it on. May have to use the old